Okay, hello everyone. So this is our monthly HEIR meeting. We'll start with the PRs. There were somehow, despite everyone being on vacation, there were 45 PRs merged since last month. I think many of them were around the me messing around with the PyPI publication workflow, but that's you working now. So if you have a Mac or a Linux machine, then you should be able to just pip install HEIR and start running some of the front end examples. The nice thing about that is that this also ships the HEIR opt and HEIR translate binaries. So if you pip install that, then you should just have access to those binaries automatically. And so start running stuff and file bugs at us if things don't work. Yeah, and we will keep going on that. There's also been a bunch of ML model pipeline improvements, mostly linear algebra canonicalizations that clean up the raw output of like a torch model and produce something that is more amenable to processing with HEIR. I believe Hongren also published his noise model design doc that explains how all the noise modeling works in HEIR. That's now on the website. And then I added a arithmetic DAG helper data structure. So this is intended to separate the work of like rebalancing or generating an arithmetic tree of operations or a DAG of operations from the MLIR constructor queries. So we use it in the polynomial optimization or the polynomial approximation right now when you're lowering like a polynomial eval op. You're doing baby step, giant step stuff to pick the actual set of operations. We had some contributors who were confused by the MLIR stuff. So now that is separating the construction of this arithmetic DAG from the materialization of that DAG as IR. And so I want to use that in a couple more places, but that lib is there. There have been a bunch of front-end improvements, including support for mod and div ops and variable reassignments, which were not being supported for some reason. The SSA IR at the front end was like not quite SSA, and we haven't quite figured it out, but the bug should be fixed. So just more programs in the front end. We updated OpenFHE to version 1.3. And then there were a number of small fixes that were related to support for that. There's a new backend emitter for something called SimFHE. I actually completely forget what this is. It's some kind of simulation engine for something. Alex, do you remember?
Yes, so this is from a work from Boston University where they did an estimator for CKKS, specifically like memory and compute trade-off estimation. So you can supply it with a cache size, and it will. It's only supported for CKKS as a backend, but it will figure out, for example, things, or it can figure out for you things such as which parameter set gives you the most throughput for a given like cost model for cache and compute, and it can also help you figure out things such as like how many digits to use in key switching, right? All these like little internal algorithmic trade-offs that you can make internally. I've actually reached out to Rashmi, one of the authors of this paper, to make sure that we actually use it correctly and that we can maybe make the output give more meaning to people, because right now it's a bit intransparent how you actually read the output you get.
Cool. Okay, so with some of the changes with the packing pipeline, we used to have like a BGV extract op and LWE, I think, extract op that were like basically saying take the first slot of the ciphertext. Like if your ciphertext is encoding a scalar, take the first slot and mask that into its like own ciphertext. Now that we have proper packing, all of that stuff is removed, so it's just a bunch of code removal. We have a new noise model for BFE that's based on the canonical embedding. And then there were a handful of improvements to average case noise analysis stuff. Some formulas were slightly off, I think, for certain types of modulus switching methods. And then we have so we have a Edwards packing solver. We wanted to export the results of that to HEIR, but then HEIR was trying to do packing on his pre-packed stuff. So now we have a pipeline option that allows you to skip the arithmetization or skip the packing stuff completely. So if you have a pre-packed input, you can just have it do the rest of the optimizations in the pipeline. The noise modeling works with a representation of numbers just in log2 in base in log2's form. So that got extracted to its own library so that all of the different noise models that want to do like log2 based arithmetic can just share it. And then, so this is a pretty big one. We have support now for lowering a polynomial evaluation that is in the Chebyshev basis to the Patterson-Stockmeyer method. So this is like the last step to supporting like end-to-end polynomial approximations of whatever you want. So that is in. And then, okay, yeah, and I already talked about the improvements to the noise analysis. But yeah, so I think the last thing with the polynomial approximation is it's not actually plugged into the pipeline yet, I don't think. So we should need to do some like end-to-end testing of like the whole thing. But it should have pretty good support, and I don't expect any major problems. In progress PRs, we have a new contributor who is working on providing a layout conversion cost model. So we have our like Felipe style packing optimization that just tries to, when determining whether it can like hoist a layout conversion through an op, it basically just counts the number of layout conversions required before and after, and then it does the minimum of that. But this one, with this PR, it will actually know how expensive it is to do the layout conversion based on like what the actual layout change is, and how inefficient or relatively inefficient it would be based on like what the pipeline will do when it's like lowering that to a sequence of rotations. There's, I think this is Hongren's colleague, is adding support for CRT decomposition and recomposition to the mod Earth dialect and the RNS dialect, which is nice. And then Asra has a series of big PRs cleaning up a bunch of old stuff in the CGGI pipeline, including removing memrefs so we don't have to bufferize, and just handling everything with tensors. So that is in progress. Okay, notable new issues. I think the biggest issue that's... Oh, go ahead.
With in progress, I'll just jump in so that Alex has context on it since I haven't talked to him in a while. But Alex, I'm also migrating the CGGI types to the new LWE types, but I just haven't exported the PR yet.
Yes. So yeah, a lot of cleanup before next week's workshop. Okay, so the biggest issue I think that has had the most discussion is potential GPU backends, not just for CKKS, but for all the RLWE schemes. So I think we filed this issue with an initial list, and then like 3 or 4 people came in and said, well, I have a GPU backend too. So at some point, I think we should add a GPU backend and figure out at least one to bet on for like an initial benchmark suite. Another thing is that we've been discussing a lot about the Parasol compiler. This is Sunscreen AI's or Sunscreen Tech, I think I forget the name of the company exactly, but their CGGI circuit bootstrapping approach. So they have the nice paper, and we have been discussing it with them. And then I believe this issue is filed by Lawrence, who he's at UCSB. He was our intern, not this past summer, but the summer before. But so he's doing LLM stuff. And so he published this paper on a tricyclic matrix multiplication encoding that he used for LLM inference. And then there's some more discussion on like, what gaps are missing for us to do LLM inference through HEIR. I've been interested in like eGraphs stuff. So I was looking at a couple papers on eGraphs. Alex posted, I think, this chess compiler that I haven't heard of and didn't look at yet. So yeah, lots of papers to read that have been added. And then there have been some sort of like cleanup things. So using arithmetic DAG in more places to simplify some code. So we had a user file a bug about adding support for loops with secret length in the RLW pipeline, and that boiled down to like we don't lower comparisons in RLWE yet. I think with the changes to the polynomial approximation, we can do that now. We might need a new op to represent like a comparison as like a sine function. I did talk to some upstream folks, and they thought it would be fine to add a sine op to the math dialect. So I'll probably just go ahead and do that. And then we can match on it easier. Yeah, I think there was an issue opened about the OpenFHE OpenFHE backend has support for like batch rotations on the same ciphertext, and we don't care about that yet. So we should like do some identification of when we can use that API and then apply it. And then that, yeah, okay. Yes, I forget what this is about. This is Rotum to HEIR. Yeah, something about packing. I think I had discussed with Edward about exporting to HEIR, and we were talking about like common things between different packing systems. I don't actually think we need to necessarily worry about unifying different packing approaches. I think we should just have each packing pipeline that does its own thing side by side, and then natural commonalities will present themselves, and we can generalize at that point. And then I've been doing a bunch more packing, work on the packing pipeline to try and get like a torch model to go through the RLW pipeline. So I have a lot to talk about that, but yeah. Anyway, okay. So I think we can open the floor to some discussion. So one of them is that now that we have like PI releases, we might want to discuss something about, I mean, this is kind of boring and administrative, but like what the release process should look like. If anyone has any strong opinions, maybe it's like a regular release schedule, or releasing when we have new features. Like that's the thing, is that like HEIR is like not quite at the point where it feels like a product yet. So it doesn't quite make sense to be like, oh, this new feature was added, so we should bump the version. It's kind of more just like some things are working, some things are less broken. We're working on different things at completely different times. So I was kind of had the feeling of doing like roughly once a month release, and I'll just like kind of do it manually and take the stuff that we've added kind of in our monthly meeting notes and turn that into release notes, and then just like bump minor versions until we have something that feels like like if we get like a torch to HEIR to backend pipeline working really well, then we can like declare a major release and then say, look at our thing. But otherwise, it's just like a way to get the Python wheels out there so that people can play with it. Any strong opinions? No. Okay. No strong opinions. Great. So I'll just do what makes sense to me.
Yeah, Jeremy, I think everything you said makes a ton of sense. So I think that I like that you're thinking about it so that when we do get that end to end, but I think that approach sounds perfect. Yeah.
I mean, it's a community project, so I want to make sure that it's not just me doing what I think is best for everything. Okay. So yeah, I don't know. I can talk about polyhedral analysis stuff on the packing side, but I think since so many people were discussing GPU backends, maybe it would be good to discuss that first. I don't know. Has anyone looked into any of the GPU backends and have any opinions about which ones would be good? I actually don't know enough about GPUs to say anything concrete about them. No.
I also know nothing about GPUs, but I did have a look through some of them, primarily from the perspective of wanting to use some of them or one of them for like doing my own PPML, AI inference stuff. But it seems like let's put it this way, out of the ones that are available, I think is it Phantom or Liberate? One of the two is like clearly the one that more and more of the state-of-the-art like AI things are using. But virtually all of them are using their own custom fork with some changes, right? So it doesn't seem like there is sort of a clear OpenFHE like equivalent dominant library. And the other one is that when these works are using GPU acceleration, they're pretty much always doing it at a higher level than the OpenFHE evaluator API. So rather than dispatching for individual like scheme operations, they dispatch for higher level things. For example, for the AI stuff, they usually dispatch, I think, at the like matmul or bootstrap. I guess a bootstrap is large enough to be like an operation, like a single scheme operation that's actually worth doing. But for like non-bootstrapping things, they tend to dispatch at like the level of an entire matmul. And so I think that presents like a bit of a conceptual challenge for our compilation flow, right? Because we have this very nice hierarchical, very MLIR flow of going from some high-level operation to a bunch of scheme operations. But now, currently, the way we do that, we lose all information about the fact that this is, in some sense, like related to, and operating on the same data and all these kind of things, right? We sort of lose information on what made up the matmul. So I think there are two ways to sort of fix this, right? And I think the reason you want to do this, by the way, is to avoid having the GPU sort of idle while you're communicating back and forth, either instructions or data, right? And I think if this is already an issue for GPU, it will be more of an issue for other accelerator, like ASIC accelerators, right? And so I think, yeah, we had a very short discussion over coffee yesterday with Jeremy about this, that one of the ways is to sort of from the top down try to preserve some of this information. And I guess that's maybe the more MLIR approach, right? We sort of maybe when we lower a matmul, we slap it in some kind of region, right? That maintains the information that these are the operations that make up a matmul. And I think in some sense, we might have to go into this direction anyway, because the way we implement a matmul in terms of CKKS operations might have to depend on the target anyway, right?
Yeah, I mean, one thing that they do in MLAR is like linalg dot generic
Yes.
has like an attribute that is the like, what do they call it? Like the hardware primitive, or the, what did they call it?
I don't remember, but yeah, I think linear generic is actually what I was thinking of as like a model here, right? Like basically an operation that tells you the nitty-gritty details of how the higher level thing is implemented. And
well, it's actually what it is linalg generic has like the details of how it's implemented, but it also just keeps the name of the op. And then like when you're exporting to a backend that just has that op as like a supported instruction, then it just ignores all of the details and it just says, okay, here's the op. So we could have something like that you know, keeps the high level primitive around.
Yeah, I mean, obviously this will be somewhat complicated for us because a matmul to us isn't just a matmul, right? I recently reviewed or read a paper that had about like an 8-letter initialism to describe like what is it, like a CCPDCMM or something, right? It was like it's like a cyclically packed ciphertext to plain text, also cyclically packed matmul or something, right? Like, so, you know, I am not necessarily saying, you know, I think I gave them a like, please fix your notation comment, but the point is that there is a lot of subtlety in like what the actual op is, right? Because we can't just plug in one matmul kernel from one library for a matmul kernel from another library, because they'll have different packing assumptions, for example, right? So yeah, I think this is something we can do. I don't think it's going to be quite as easy as sort of like the BLAST style thing of, oh, I just, you know, here's a fixed set of like 100 operations that people usually have, and we have a common understanding of what exactly they are. But the top-down, I think, solution is, you know, something that I think feels very MLIR, like idiomatic, right? The alternative is the bottom-up approach, where we just, you know, we take a bunch of scheme operations, we don't change much or anything about how we generate them at the moment, and then we try and do sort of kernel fusion style things at the rear. And I forgot who it was. I think Ed, it was a colleague of yours, right, who came on a few like office hours ago and talked about actually working on something like this.
Sid has some like kernel scheduling fusion thing where it's like dispatching based off of the instructions and like how kernels are being deployed onto GPUs. Okay, granted, I don't really know too much about GPUs as well, so this is like through secondhand conversations with him. He has basically like a kernel scheduler where it'll basically look at the low-level HE operations and figure out how to then like vectorize and create like which are these different kernels to then deploy onto the GPU.
Yeah. Actually, it makes me like, we all saying like, oh, we don't know a lot about GPU, right? And I think that might also hold true for most people at my company, right? But I think I remember there were some people at NVIDIA that were interested in FHE things, right?
So
They sort of,
I've been in contact with them like
Yeah.
a bit more. They are, I think they're like backing away from supporting FHE specifically and more going to like general cryptographic computation toolkit. So like focusing more on like the NTTs and stuff that is useful across ZKP and
Yeah.
MPC and FHE.
But I think it might still be really interesting because in some sense what they were doing, and I think what their research was interested in, was sort of seeing, are there any like tiny changes they can make to the GPUs to make, big impacts on how crypto works on GPU, right? Which is a great thing, right? But in some sense, that's like way overkill to what we actually need. So maybe just seeing if like what their opinion is, maybe having a meeting with them to specifically discuss, okay, what can we do on like current gen GPUs with like current tooling, right? And maybe they have a perspective on which of those two approaches they think we should pursue, right? Yeah, I think they have they implemented a really competitive CGGI library on GPU, but I think they never made it open source, for example, right? And so maybe if they already have a CKKS implementation, I wouldn't be surprised to see it maybe outperform all the open source versions, for example, right? So those are, I think, questions that we should ask them if you're already in contact with them the next time you meet with them.
Right. Yeah, and I guess I don't know, Alex, did you have like one particular GPU backend that you thought was the most promising looking?
Yeah, I think it's the Liberate one. Again, like I might be confusing this with Phantom right now, but I'm pretty sure it was Liberate that was the one that was actually used by most of the like PPML AI papers now. Specifically, I think the Nexus paper, which is kind of state of the art. The evaluation is a bit, hard to read sometimes. That one has code for the paper available, but it does include the bootstrapping extended version. So I think if we want to do GPU acceleration, we have to have a bootstrapping implementation, right? Because that's why people want to use the GPUs, to make the bootstrapping fast. And so I think specifically any of the like bootstrapping enabled forks of Liberate would be an interesting option. I think that also is a bit of an issue though with like, mono repo stuff, right? Just from a administrative, like this is like a random fork living in some random like academic code proof of concept thing, right?
I haven't looked into their. Do they have Bootstrap support? Let's see. Okay.
Not in the upstream repo as far as I know.
Okay.
Unless they added it since I last looked at it.
Okay. Yeah. So on a different topic, so in the packing pipeline, I think I've been doing a bunch of research studying polyhedral analysis and trying to figure out, I mean, so like the manipulations we've been trying to do of our packings as we implement Felipe have been like less than, let's say it hasn't been up to my standards of like engineering quality. Like it's messy and confusing and error prone. And I think that like generalizing slightly the concept of packing to something that fits better with polyhedral analysis will allow us to make this much simpler at the risk of being slightly more dependency heavy. So I had taken written my own Python proof of concept of like what this thing looks like, that just kind of like does like a little Python fork of the main basic concepts of polyhedral analysis from MLIR upstream. And then I convinced myself that it made sense and that it would do everything we needed to do, at least in the Felipe part of the pipeline. And then there was sort of the last question I had was like basically what it does is it represents a packing in terms of integer relations, like a set of integer constraints that relate the index space to the like data index space to the ciphertext index space, and that you would basically say, okay, there's an entry in this relation if this data item goes in this slot. And that is just like very convenient for doing things like hoisting through an op, because you can compose the relations together on either the left side or the right side. And then the only difficulty is that after you do all of these operations, you get some relation that is basically has like lots of intermediate variables in it that can be eliminated. But if you want to eliminate them cleverly and efficiently, you need like the more sophisticated algorithms from the polyhedral analysis community. So I tried doing it myself and like didn't get something that was fully generic, but like basically like that you need to do that once you've done all of your optimization of the packing. Then you need to take your packing and materialize it to like a set of loops that actually assign data values to ciphertext slots, and that like requires you to basically enumerate all of the entries in the relation, or have some nested version of that enumeration. And if you don't get rid of all these local variables, then it's like too slow to realize this. And so the polyhedral analysis community has like lots of algorithms for dealing with this. And so then I said, okay, I want those algorithms. So I was trying to figure out, this is the part that I still haven't finished, is that I was looking at the integer set library and MLIR's Pressburger lib, and I wanted to figure out like, okay, how do I take like the concept that I need, like which is like hoisting this relation through like a matrix vector multiplication op, which requires like kind of like peering inside the relation and connecting some variables together, how to express that in terms of the API that is provided by one of these two things. And I haven't quite got it there yet. But and it's funny because I think ISL was written by Tobias and his students, right? Is that right? Yeah. And so I asked Tobias, I had a meeting with him, and then I like sent him like a follow-up. And he was like, "Oh, it's been so long, I forget how this API works." so it's quite funny. But I'm not sure or if there's strong opinions. Like I'd prefer to get it working with MLIR's Pressburger lib, just like directly, but that is like an incomplete mirror of ISL. And so like I'm hoping I wouldn't need to add ISL's dependency in HEIR. But I'm wondering if anyone has experience with ISL, or if there's a thought on, yeah, I think trying to avoid that dependency. I'm trying to figure out how to get it to work with ISL right now, just to make sure that, you know, with the thing that has the most available expressive power, I can do it, what I need to do. And then try and figure out if MLIR's subset supports that same thing. But I don't know. I haven't been able to get it to actually work, and it's for like weird reasons. It's like there's like 7 different APIs that I think would do what I need, but I can't get any of them to like actually run without raising an error. Like it's some weird assumption that it thinks should be there, and so I haven't figured it out yet. But yeah, so this is like, unfortunately, this is kind of blocking a bunch of the packing and ML work. So I'm hoping, I don't know. Next week is workshops and team summits and stuff, so I'm not sure I'll have much time to do it. Maybe on like plane flights or something. Anyway, so that's where this is sitting basically. Is I have to get this proof of concept working, and then I feel like there's a pretty straight shot towards implementing in HEIR. So that's, I don't know. That's all about that. So okay, this meeting is going very quickly. We usually are talking until the end of the hour, but we're out of topics. So I will just leave the floor open in case anyone wants to bring up any topics for discussion. And then if no one has anything to say for a few minutes, then we'll end it.
So I have a question about the polyhedral analysis proof of concept. If you're given like a tensor operator, like matrix multiplication, how would you handle alignment of like 2 mismatched layouts with this particular system?
So there's a, I guess I'm not quite sure. I mean, so we have like an op in HEIR that's just like a blanket layout conversion. So you're saying like, how is a layout conversion represented?
I guess it's more of, if you're given 2 layouts, how would you know if you can just apply like a matrix multiplication operation on top of it? Like if these two layouts can just be directly multiplied and then summed along a dimension, or if a layout conversion is needed?
That's a good question. In the current layout system, we basically say like we like recognize the layout formula like directly. We say like, okay, your layout formula has to look like this, or it has to simplify to this. And if not, then we just insert a layout conversion so that it looks like that. But the actual process of doing a layout, like if you have two layouts and you want to convert between them, the polyhedral analysis way is like very simple, because you can take like a layout is like a relation here, and then a different layout would be a relation here, or I guess it would be like here. And then you can just invert the first one and compose it with the second one, and then you get the layout conversion as a relation between these two things. So it's actually like very, very straightforward. And then like under the hood, the polyhedral analysis data structure will like simplify all the formulas involved in doing that composition. And then you'll get something that looks like just like a relation between, like a permutation between the two like packing index spaces. And then you can like enumerate that to like an exact permutation if you want. But like, I guess there's a question about like, you know, say that like it's actually something that's compatible with a matrix vector multiplication, but like we didn't recognize it as such, and so then we added this thing and it does all this stuff, and then you get something that ends up being like the identity permutation, but like maybe it's like hidden. I mean, I feel like that would be recognized, and then when you're doing the hoisting in the Felipe style, you would say, oh well, this layout conversion is actually free because it turns out to be and in
The
that
identity.
case, our implementation of the Felipe will actually identify when, like the cost model that we just got added, right, would say, oh, this is a free layout conversion. So it would be the same as if there were no layout conversion required. That's kind of like a messy way, right? That's like saying like, oh, like we're going to just ignore the problem that you said, and then it will kind of work out because we will measure the cost of that thing as being free. And but like ideally it would be nice if and I think the polyhedral analysis stuff would allow us to do this and say basically like, okay, like I guess we could just like do it directly. We could say, okay, do a conversion and then check to see if it's the identity. Just like doing that eagerly and then saying, okay, well then you don't need a conversion if that is the case. But yeah, right now it's messily. It's kind of like, oh, just look at the formula, and if the formula looks like it's supposed to look, then it's compatible.
And then the cost modeling here is essentially you would run the algorithm to do like the conversion shift network, and then just count like the number of ciphertext operations there.
Yeah, I think this actually came up in the discussion of this PR here, where I wasn't exactly sure what the cost model should be once you've constructed this network. At least in the like a graph coloring thing, what you get is you get a set of rotation groups, each one of which would evaluate like it could be run in parallel basically, and they would each evaluate a set of like a power of 2 decomposition of the rotations, but not necessarily all powers of 2, right? So like you would basically say, oh, this one needs to shift by like 1, 2, 5, or 1, 2, 4, and 16 or whatever, and this one needs to shift by 2, 4, and 8. But you can run each one of these groups in parallel as like its own shift network. And so I was thinking that like, okay, maybe the right cost model there is like latency, in the sense that you would look at the deepest of these rotation groups, and then you can assume you run them all in parallel. That is like one cost model, just counting, rotation ops, and like total cost of all of the operations would be another approach. But like I don't have like a strong opinion about which is the right cost model.
No, I think that makes sense for now in terms of just like counting the number of operations based off what the layout conversion shift network gives you. I'm just curious too, like in the future, if we're also trying to figure out costs with relation to like bootstrap placement, we would also need to know the multiplication depth, or like how many like rescales are used within this like conversion shift network.
That's
or
true.
how many just something something to bring up.
Yeah. Okay. Go ahead, Alex.
Really non-technical point, but I don't know what we're currently using for HEIR.dev for the website generation, but can we change that or the theme or something to make it look a bit more, nice?
You don't like the theme? I mean, it's Hugo.
that could be like a hackathon Monday thing for somebody who's interested in doing something but not like super into MLIR. Yeah, I guess with Hugo, there's a lot of themes and templates that we can use to maybe, I don't know. I just recently realized looking at all of these like, flashy new startups and their presentations and slides about their tool chains that, while we have a very lovely logo, our website does look a lot like sort of the documentation page of an LLVM tool, which is,
Does it look too antiquated?
Hey,
Like
the LLVM tools have a lot more usage than any of those startups. So
fair point, but I think let's put it this way. I think they have a lot of use despite their website design, not because, right? So yeah, I don't know. I feel like I think also we have this like big diagram of like the dialects and something on the front of the webpage, right? Which yeah, I think we need to think about.
I wanted to replace that with either a different picture or just no picture.
Yeah, I think we need to somehow think about like how we pitch HEIR to people. I think we're now at the point where we're reasonably close to being useful to people other than compiler researchers. So I think we need to maybe maybe like a big scary diagram of all the dialects isn't the way to go anymore.
Yeah. Yeah, I was hoping to rewrite some of it before next week's workshop, but like I was also looking at I think the only part of the like actual documentation of the website that's not auto-generated is the pipelines page, which I don't think hasn't been touched despite all of our refactorings of the pipelines. So it would be nice at least to update that for.
Oh, actually, I think I have a branch for that. I asked my favorite LLM to like just grab all of the like existing pipeline stuff and like to just fill it out. So yeah, I think with some like light editing by an actual human, that should be really easy. I think it would be even better to have that be auto-generated though, but I think MLIR doesn't do that either, right?
It doesn't, no. And I would love to fix that somehow. But yeah, I think the very least, what is it here? Let's name and shame ourselves on camera. Okay, so here's our website. So the theme is called Doxy, I think. I don't see the actual link to the theme, but yeah, it's supposed to be like for software documentation websites, and so it's got like all the stuff here where you can go and complain about stuff.
I mean, has anybody actually ever clicked on any of those?
I don't think so.
So I think like I don't like if I need to make a documentation change, I like open my local repo copy, right, and edit the markdown file. So yeah,
I mean, I could get rid of those. I think that's just by default it's up there.
Yeah, I don't know. Maybe we have a few. I guess we have. I don't know. Like Edward, I guess you've recently had the fun experience of like having to work with HEIR, right? Like as like just trying to get something to work. How useful was the documentation actually, and like which parts were useful and which parts were less useful, right?
So far what I did was I went through like the getting started, and then I tried running the dot product example as like the first step. And then I think there's like another documentation page that talked about all of the different passes that you can like turn on and off. And those were like the 2 points that I like kind of used, where it was like, okay, how do I like turn off the layout assignment pass if there's one and stuff like that. So far I think like reading it and like using it, like running the example was like, it was fine. And then I think the other thing too is just like, if there were any questions that I had, like we were all like readily available to answer questions on Discord. So getting started wasn't too bad on that front.
Yeah. I think that makes me think that maybe something like not just a bit of text for the pipelines, but actually, especially if we auto-generate it, having the actual list of passes with like a link to the actual pass description would be really useful. So, and like also the options, I guess we don't really specify, like if we could extract the options and the like passes in each pipeline in some way, that would be amazing, right?
I think that that's actually like somewhat hard to do, like the way that the pipeline options. Actually, maybe it's not.
So you know what you can do? You can do dump pass pipeline as an MLR flag. I forget exactly what it is, but it's something like dump pass pipeline. And so we could take one of our like end-to-end tests that exercises this pipeline, dump the pass pipeline, and then I don't know what we would do with that, but like extract each pass from that and make a link to them, or like show it as like a diagram that shows the sequence of passes. I mean, it's also that pass pipeline is partially configured, right? Like if you change some options, then it will give you a different pipeline because if you skip packing, right, then the printed pipeline will be different than if you don't skip packing. I don't know about extracting the flags of the pipeline though.
I think we should do it manually for now until we find a way to maybe automate this. But I think, I think, like, because having to go through a list of passes, I mean, I sometimes have to do the same thing upstream with like the even longer list, I think, of passes in MLIR. And it can be pretty brutal because it's not entirely clear what a pass is supposed to do sometimes, right? Even even if the name is sensible, there's a lot of different interpretations of what that sensible name might actually mean. And so I think, I also think we should find maybe like a standard format for actually documenting passes and pipelines, especially I think pipelines, we only have like a few high level ones, right? But in terms of, I mean, we have like
put in the table, Jen.
Like we should have like a little like template for what we put in the table. Like definitely keep what we have right now as like the generic description. But I think also maybe sort of like expectations of the input IR and like guarantees of the output IR, because I think those are the things that I like. Now that we actually have enough people like making contributions to the compiler in a somewhat regular fashion, like especially like Hongren doing a lot of things like very quickly, I'm like, I actually need to like sometimes look at the code and be like, wait, why doesn't this work? Oh, this assertion here, right? Or like this exception is triggered. And I think having a better documentation of what exactly these things expect the sort of input-output relation to be for each pass would be really helpful.
Especially, I think a lot of it is also depending on having particular attributes.
Exactly.
And previous passes being run, that kind of thing.
Yeah, and I think it's sort of like clearly there's like, here's like the like if it supports a dialect, like are there any operations it doesn't support, right? It's like a big one, but also and I think this will also then allow us to better differentiate between, or like allow other people that aren't familiar with like the current development to differentiate between this is a bug that I need to file a fix for versus like this is a design choice that we made and you're just not gonna like you're trying to put the square thing through the round hole kind of thing, right?
Yeah. So you mentioned we should have like a team tech debt cleanup thing, and I feel like that would be a really good like tech debt, and also teaching everyone on our own team like all the parts that we haven't been familiar with, right? Like going through.
I feel like I think Astra has been on that journey already, right? Like memref removal type systems, which
yeah. But like, I mean, I feel like I've been the only one working with Hongren on like populate scale and all of the noise analysis stuff and all of the parameter selection stuff. And so like I have a good understanding, like, oh yeah, like he wrote these passes expecting certain parameters to be there and certain management attributes to be there. But I feel like that's. Yeah. Plus, the examples are also like maybe, I mean, it'd be nice to auto-generate some examples from tests because like the syntax is now out of date. Like,
maybe not auto-generate examples, but at least automatically check them during CI, so that like we try to actually run the examples or something. And like just,
I mean, I was thinking take examples from test cases.
Yeah.
Instead of having this example hardcode here, have a name of a test file, and then during website generation, it would go fetch that test and strip out all of the checks, and then like maybe even run it. Like that'd be cool. It would run it with the pass
and put the output in as well,
show the input output and the pass being run. Like this seems like it's doable.
Oh yeah, that seems even way easier than the pipeline extraction. So I think that would be a really cool addition to the thing. And then maybe we can brainstorm a bit on offline on what exactly we want that like pattern of like documentation to be for the passes. And then
I
yeah,
think it should just be like preconditions, post conditions.
Yeah.
And like they can be free form, whatever
Yeah.
whatever seems relevant to put there. I like that plan. I need to remember to file an issue for this.
Awesome. Oh, and I just realized how like I know that we had this like hair play thing, right? Like a Google collab with that. That was demonstrating some things with hair, right? How close are we to making the getting started thing a runnable notebook?
Oh, I guess now
I think we could just do that,
yeah.
right?
Now we can
Yeah.
just do it because
Yeah.
now we just pip install
Yeah.
HEIR and we don't need anything else.
Yeah, so I think maybe that would be like a simple change we can make. Just basically take that page and turn it from a markdown into a notebook. And then we need to figure out how to like, have it like display properly on the web page and things. But yeah, I mean, that's like kind of the reason why we want like pip installable, right? So. Yeah.
I guess. What else do we say? Oh, you want a different theme?
Just I guess like actually very
Or you
small
want like a
things,
landing
remove
page? You want a landing page that's different from the like.
Yeah,
I feel like you're happy with the website, except you just don't like the homepage being this. You want the homepage.
Yeah, I
to
think
be
honestly
like
the documentation
a
part is
startup,
fine.
like,
I think we
threefold and then a
Yeah.
link to documentation.
Yeah, I think we need like an actual landing page. That's like a thing. And I think even for the documentation page, it might make sense to disable the like navigation things on the right, if nobody uses them ever anyway. But yeah, like a landing page would be nice. But I think otherwise, I'm happy with the doxy theme for the actual documentation. Like the parse and pipeline documentation looks great. Yeah, CryptoLab, I think.
Yeah.
What does CryptoLab have as a? I mean, okay, that's like the world's best.
It's
yes.
so flamboyant.
No, I honestly, I don't know. Like we can,
Well,
I don't know. We can
CryptoLabs has,
brainstorm
like,
on like what the inspiration should be, but yeah, I guess that's more like a login page. But yeah, what is?
No, CryptoLab has like they have like all these like animated GIFs that don't do anything. That bothered me. I was like, why is there? Oh, this is it? Or is this?
Oh, that's like that's
Yeah,
Like, is this what you want for the HEIR website? You want like one of these?
It's funny because that's not the right crypto lab, but that's exactly what it's like the same threefold type of thing. Like it's the same.
Like honestly, I didn't realize that was the wrong CryptoLab. Except like, oh, look, they must have redesigned the website. But no, like that is okay. No, I think a much more close contender would be HEIR, the landing page that Latica has for HEIR. There, like, because that's like the same kind of like level of abstraction. I don't actually like the above the fold like weird image that like looks very AI generated. But if you go to the link I just posted in chat, you can in like Google Meet chat. Okay, and like I don't like the above the fold thing, but if you go down and get rid of the cookie banner and all that stuff, like okay, like what is this? HEIR, like this kind of like diagram, like why, like and why hardware vendors choose HEIR, like right, like I mean, I don't know about anybody choosing HEIR so far, but I definitely think we can put some. We have some testimonials, right? We collected some from I think Optalysis at least. I remember maybe Konami gave us one. I can definitely get one from Intel, right? So we like this is kind of what I mean. Like, what is HEIR in the FHE stack and why people choose HEIR, right? Like that would be like a landing page. I think that we could, be inspired by much more. Like I'd rather be inspired by this than by the CryptoLab one. Either one.
For me personally, anytime I go to a website like this, my eyes just like glaze over and I don't see any of the information. Like it's
I
all
don't think you're the target audience for the landing page, Jeremy.
I know. That's just me, like jaded from years of reading stupid startups landing pages.
Yeah, I mean, also I don't need it. Like we don't need it to be super animated things, but I just mean like sort of like maybe for people. Like I think the current starting page is fine for people that know that HEIR is an FHE compiler standardization project doing like the things we do. But the point is, like, if people don't know what HEIR is, it's a very, like, not very helpful page, right?
I do think we have so many really pretty diagrams from our slides that we can
Yes.
just use instead of like these, like this one, the animations, like, yeah, just think about
Yeah,
that.
like,
We have like lots of pretty diagrams and like stuff like that.
yeah, I think like we've done a really good job pitching here. Like, I mean, like the list you have of like the goals of HEIR, like I don't know, did Shruti do that slide at some point? Like, I don't know, like I associate it with like the HEIR talk, right? Like there's like this like why HEIR, right? Like why, like that, those like 6 bullet points or something, like really nicely things like that should be like content for the landing page, I think. Basically like the first 10 minutes of the HEIR talks, right?
Like you want this to be a HEIR pitch, not like the landing page to be a HEIR pitch.
Well, I think like at least like some context, right? Because I think it's one thing to say HEIR is an FHE compiler, right? Which is like, sure, whatever. And it's built using MLAR, and that's like great and all, but I think we can just give it like, we can just have like one landing page sort of that says, hey, before you dive into like, here's all of our dialects and like, here's all the nitty gritty of LLVM and MLAR, right? We can have like one nice landing page that, when we go present HEIR to somebody and, all the managers in the room end up, opening the phone and browsing to the page, I want them to see something that like, gives them a why and not just a what, if that makes sense. So yeah, I mean, I'm not like super strongly, this is by far no means our like highest priority, but I just noticed that like, we can probably make HEIR look a bit more appealing to get into by not, sort of throwing this really, like technical diagram at people first thing they see.
Yeah, no, I don't like the diagram either. So I would prefer to move the diagram somewhere else. But yeah, I mean, this page even could be like this page instead. Like instead of having this be like a blanket thing, this could, like when you click on docs, it could go to a page that shows like that diagram, and then this landing page could be something else. I mean, I'm in support of that. I definitely think it needs rewriting.
Like I think our documentation page is fine. We just don't have a web page, if that makes sense, right? Like we don't really have an actual like web page. We just have the documentation page, and I think we do need a web page. And like I think like this is sort of like, and the same thing I think goes for our like GitHub README, right? We probably want to say, link out to the, like, rather than having a bunch of, I think currently we have a bunch of like a mini tutorial in there for like how to get started.
I rewrote it recently.
Oh, perfect. Yeah.
So now, I mean, like
that's awesome.
it doesn't have like a why, but it does have a just in pip install HEIR instead of like try Jupyter weird stuff.
Yeah, no, I think actually, I think the new that looks a lot nicer. I think we definitely want to link back to our like full getting started tutorial and things, right? Yeah, kind of. But yeah, so I think our README is actually looking a lot nicer now that, I guess the pip install made all the ugliness go away. But for the website, I do think we need like an actual website rather than just a documentation page.
Okay.
And as well, it's a very good point. We have so many great like visuals from the slides. Should be very easy to put something together.
All right. Any other topics? We're just about at the end of time. Oh, we managed to fill it up.
Yeah.
Sorry for ranting about website design for 10 minutes.
All right, cool. Well, then I will see everyone, see some of you hopefully next week at the workshop. All right, bye.